All right, in this lesson, in 10.3, we're looking at area of regular polygons. Now, before we go any further, regular, if you remember back from earlier this year, we talked about regular polygons were those polygons whose had all sides are the same and all angle measures are the same. So it doesn't matter if it's got 4 sides or 100 sides, all the interior angles will be the same and all the side lengths will be the same. So let's go through here into our first part. So we have some parts of the circle we're going to look at in the polygons. The area of a regular polygon is related to the distance from the center to the side. Now, the term circumscribed. So you can circumscribe a circle around any regular polygon. That means like you're going to draw a circle around the polygon. They both have a center, and the centers are in the same spot. Now, the center of each regular polygon is the center of the circumscribed circle. The radius of the regular polygon is the distance from the center to a vertex. So notice that each vertice is on the circle, which means the distance from the center to any vertex would be the same thing as the radius, because the radius of a circle is from the center to any point on the circle. A new term that we're going to use is called the apothem. The apothem is what we call the height of this one triangle here at the bottom. Now, in a regular polygon, we have as many sides we have that many congruent circles or congruent triangles around the circle. And so the apothem is the height of that one triangle, not the height of the polygon, but the height of the one triangle. Now, postulate 10.1 says if we have two figures are congruent, that means their areas are the same. So if we have 8 sides in our polygon, that means we have 8 congruent triangles. Therefore, we have 8 congruent areas. Now, the equation we're going to use in this lesson is going to be that the area of a regular polygon is half the product of the apothem and the perimeter, where A stands for the apothem and P stands for the perimeter. Perimeter, remember, is the distance around an object. So if they're all the same, if all sides are the same in our regular polygons, then you're going to take the number of sides times the side length to get our perimeter. All right, central angle. This is a term we're going to use a lot in the near future. The central angle is the angle that's formed between the two radius, or the radii, and it goes as it goes around the circle. Now, like we said before, this is a circle goes all the way around, so that the sum of these measures should be 360. So the figure at the right is a regular pentagon with the radii and the apothem drawn. What is the measure of each numbered angle? So I'm going to give you a little bit of setup for this lesson. The first one we're going to find is angle 1, and I have a name for each one of these. The first one for angle 1 we're going to call is the central angle. The central angle is the angle as it forms around the center of our polygon. So the central angle is going to be what we call angle 1 here. And to find our central angle, we're going to take 360 degrees, as we talked about it in a circle, distance all around, divided by the number of sides, n. So in this case, we have 360. Pentagon has 5 sides. So 360 divided by 5 is going to be 72 degrees. That means that each angle around the center is 72. I didn't draw this one in. This is still 72, but we're going to write on this here in a second. The second angle, angle 2, is what we call the half angle. So that is found by taking your central angle and dividing it by 2. So in this case, our central angle is 72 divided by 2, and so our half angle becomes 36 degrees. So now we're looking, that means that this angle right here is 36. We cut it in half. This angle right here is also 36. So the apothem, which is this red line right here, separates each triangle you can draw it from any different side, cuts it into two congruent halves. We get two congruent triangles. So this is 36 here, which means our two base angles would be the same, because this is an isosceles triangle because all of these radiuses have the same measure. And because the apothem bisects, the apothem is a perpendicular bisector, so therefore it cuts this central angle in half. So the last one is angle 3, and I call this just the third angle. Nothing fancy. So angle 3 is going to be found by just by looking for this angle here. So we're going to take our 90-degree angle and we're going to subtract our half angle. So this is the pattern you take. 360 divided by the number of sides to get our central angle. Take your half angle, divide it by 2, and now we're going to take 90 minus our half angle. So 90 minus the half angle is going to become 90 minus 36, which is going to give us 54. So our angle 1 is 72, angle 2 is 36, and angle 3 is 54. All right, so let's take a look at example 1b. The figure at the right is a regular octagon with the radii and apothem drawn. What is the measure of each numbered angle? So I want you to find the measures of angles 1, 2, and 3. Now remember, this is an octagon, and only the picture is only drawn of half of it. It won't always draw the entire picture. So we know the number of sides by looking at the directions here in the problem, and it says it's an octagon, which means it has 8 sides. So find the measure of angle 1, 2, and 3. Pause the video, and when you're finished, hit play and come back and check to see how you did. All right, so let's see how you did. Angle 1, 360 divided by 8 is equal to 45. Angle 2 is half of 45. It's our half angle. So we get 22.5 degrees. Now remember, you're not rounding off. We want to know exact answers here in these angle measures. And then angle 3 is going to be 90 minus the 22.5, our half angle, and that gives us 67.5 degrees. All right. So let's take a look here at finding the area of a regular polygon. Now before we do this, there is a series of variables I want you to write down in a series, and this is what we're going to use in each one of our problems in this lesson. So what I call this, I came up with it, is Nespacha. Okay, it stands for N, we have S, we have P, C, H, and A. The N stands for the number of sides. So the number of sides in any polygon, this is our N value. S stands for our side length. P is our perimeter. That is the perimeter of our polygon. C is going to stand for our central angle that we will use when trying to find a missing side length or apothem. And along with the central angle, this is the half angle. Okay, the last one here is the A, little a. This is going to stand for the apothem. Now you're not going to have to write out each one of these words every time, but I do want you to write out the abbreviations. So N, S, P, C, H, and A. The two main ones that we need are going to be the perimeter and the apothem, because the area equation, area formula, is 1/2 apothem times the perimeter. So in this problem here, the right angle symbol did not show up, and neither did the apothem very well, so we'll go ahead and draw this. So in this figure here, they tell us it's a regular decagon, which means that has 10 sides. So we fill out the N as 10. The The side length, if we look on here, is 8. 8 is written here, so this means our side length is 8. Now from this point, we can find the perimeter by doing 10 times 8. Number of sides times the side length gives us our perimeter, so we have 80. Now, in this case here, we have the apothem as well, which is the 12.3. So we skip down here to 12.3. Because we have both the perimeter and the apothem, we do not need to find the central angle. So from here, we're just going to plug our numbers into our equation. 1/2 times 80 times 12.3. Doesn't matter what order we put the apothem and perimeter in. We're going to multiply them in any order. And so this will give us the solution for our area is equal to 1/2 of 984, and half of 984 is going to give us 492. Now because this is once again area, this means our units will be inches squared. So we have 492 square inches. So the two things we have to have are the perimeter and the apothem. So NSPCHA, N-S-P-C-H-A. Write this on every problem to identify the information and then plug in our perimeter and apothem in, calculate it times 1/2. All right, so let's take a look at the next one. There's no picture in this one, but it says, what is the area of the regular pentagon with an 8 centimeter apothem and 11.6 centimeter sides? So because we have both the apothem and the side length, then we can now calculate everything we need to know, so we don't need to draw the picture. So find the area of this regular polygon, pause the video, and come back when you're done. Okay, so number of sides is 5, side length is 11.6, which gives us a perimeter of 58. Apothem is 8, so we've got our perimeter, we've got our apothem. Come back and multiply them in. 1/2 of 58 times 8 is going to be half of 464. And that gives us 232 square centimeters. All right, so we have 6 practice problems. I want you to pause the video, work out all 6, and then come back and check to see how you did. All right, so let's see how you did. All right, in this first one here, we have to count the number of sides, which is 7. The side length is 13.9. Perimeter would be 97.3. Apothem they give us is 14.4. 1/2, 97.3 times 14.4 is 700.56. Tells us to leave our answers in the simplest form, which means this has not been rounded off. This is the complete decimal we got. The next one, number 2, we've got 8 sides this time. Side length is 12, which they gave us, and perimeter is 96. Apothem is going to be 14.5, so the area is found by doing 1/2 of 96 times 14.5, and that gives us 696. Let's go to the next one. Now number 3. We have a triangle, so it's got 3 sides. Side length is 8. Give that to us here. Perimeter gives us 3 times 8 is 24. The apothem is 4 radical 3 over 3. So that's what this line right here is pointing to this. So 1/2 times 24 over 1 times 4 radical 3 over 3. So because we're multiplying by fractions, I turn everything into a fraction. So my whole number here becomes 24 over 1, which makes it a fraction. 2 goes into 24 twice, which is 12, and then 3 goes into 12 4 times, so this is how we got the 4 up here. So 1 times 4 is 16, and this becomes 1 times 1 times 1, which is just 1, so we get 16 radical 3. So we do not want to calculate the radical unless they tell us to. The next one here is a pentagon, so it's got 5 sides. Side length is 7.5, and the perimeter, we then multiply these together to get 37.5. The apothem is 5.1. So we're going to multiply 1/2 times 37.5 times 5.1, and that gives us a decimal of 95.625. So if they didn't tell us to round, we're going to write the entire decimal. So let's go to number 5 and 6. Number 5, we have 6 sides. The side length is 10. Perimeter would give us 60. The apothem is 5 radical 3, which was given, so now it's a matter of setting up our fractions. 1/2 times 60 times 5 radical 3. 2 goes into 60 30 times, and 30 times 5 is 150. Bring down the radical 3. And the last one, pentagon, and then gives us side length of 10.6. Perimeter gives us 53. The apothem is 7.3. Multiply your numbers out. 1/2 times 53 times 7.3, and that's going to give us 193.45. All right, so this concludes the first part of lesson 10.3. The second part is where we're going to start working and finding the central angle and the half angle.